AWS Proton is a fully managed application delivery service that enables platform operations teams to provide consistent architecture across an organization and enables developers to deliver their applications on approved infrastructure using a self-service interface. In this demo, we'll see how to set up all the different tools our development teams need for infrastructure provisioning, code deployments, monitoring, and updates. Let's begin by opening the AWS Proton service page in the AWS console and clicking Get Started. Before development teams can use Proton to deploy services, we'll need to create a service template for them to use and a standardized environment where they can deploy their services. To create that environment, we first need to create an environment template. Let's go ahead and do that now. A Proton environment template is a reusable bundle of configuration files that define the metadata and infrastructure resources needed to create a given environment. For this demo, we'll be creating a template to provision a new environment using one of the sample template bundles provided by the AWS Proton team. The sample template bundle consists of a manifest.yaml file, which lists the files used to define an environment's infrastructure, a schema.yaml file, which defines the input parameters used in the infrastructure templates, and a CloudFormation.yaml infrastructure file, which defines the infrastructure itself. We also have the option of providing our own template bundle, which will build a custom environment according to our organization's best practices. Or we could tell Proton to use some existing provisioned infrastructure that we manage on our own. Let's select the Fargate Environment sample template bundle, fill in a template name and description, and leave the rest of the options alone. Next, we'll create a service template. A service template, similar to an environment template, is a reusable bundle of configuration files that define a complete set of resources. The sample Fargate Service Template Bundle, like the Fargate Environment Template Bundle we just saw, also consists of manifest, schema, and CloudFormation YAML files to define the infrastructure, but also contains an additional CloudFormation.yaml and manifest.yaml file to define a deployment pipeline for the service. We'll fill in the service template name and description, and leave the rest of the options alone like before, except for the compatible environment templates. Here, we'll make sure to select our Proton demo environment template from earlier. This will ensure that anybody using Proton to deploy the service will deploy it to a compatible environment. After clicking Create Service Template, we're asked to configure an account role. This is the IAM role that Proton will use to make API calls to other services, such as CloudFormation, on our behalf. For this demo, we'll have Proton create a new service role for us. However, we strongly advise platform administrators to read more on Proton's access control and scope this role down to the minimal set of privileges required by the templates they intend to use. Before our developer teams can deploy their own Fargate service with Proton, our last step as the platform operators is to actually build the environment they would be deploying to. Let's use the environment template we created earlier to do that now. We'll choose our Proton demo environment template, call this a staging environment, choose the default service role we created, and click Next. It's now asking us for some VPC and subnet CIDR ranges because the schema.yaml file in the sample template bundle said to expect some. These values are optional though, so let's leave these fields blank to accept the defaults. The deployment was created and is now in progress. While that's running, let's repeat the process to create a production environment too, and let's specify some CIDR ranges this time as well. Creation of the sample environments should only take a few minutes to complete, but for longer deployments, we can switch over to the CloudFormation console to follow its progress in more detail. Great! The environment is ready and now just needs a service to run in it. Our work as platform operators is complete for now, so let's see how the next steps look from the perspective of our developer team. We're now logged in with a separate AWS Proton developer role, which has the default AWS Proton Developer Access IAM policy attached to it, as well as read-only access to AWS CloudFormation, AWS Code Pipeline, and a variety of services consumed by our sample application, such as Amazon ECS. Let's create our first service. First, we go to Services in the Proton service page and click Create Service. Next, we select the Proton Demo Service template and click Configure. We'll give it a name and description, then configure the repository settings. For this demo, we already have a GitHub repository connection established that allows us to detect source changes. To configure your own, click Create Connection and follow the steps. In this case, we'll have it deploy from the main branch of our forked AWS Proton sample Fargate service repository using the existing AWS Proton demo repository connection. Next, we'll configure two service instances, one for each environment that we created earlier. First, we'll create a staging service instance that will deploy to the staging environment using whichever defaults are specified in the service template. And then we'll add a production service instance for the production environment. This time, since it's for a production environment, let's have it create 3 medium-sized Fargate tasks instead. Finally, we'll leave the container image and pipeline inputs at their defaults for this demo, as the pipeline configuration within the sample Fargate service template bundle for AWS Proton takes care of building the container image and configuring our Fargate task definitions accordingly to use it. Proton will create the service and service deployment pipeline, and we can follow the progress using the CloudFormation stack events log. Then we can watch the deployment pipeline itself deploy our sample application to each environment. Now that our application is deployed, making changes is just a matter of pushing new commits to our repository, which will be detected by Code Pipeline and begin a new deployment cycle. Since all this infrastructure is in our account, we have full capacity to manage, update, and troubleshoot as required. For example, platform operators can review CloudFormation stack events for issues when deploying environments, developers can see details on code deployments within Code Build and Code Pipeline, and we can make changes to the underlying environments or services by creating a new minor or major version of the corresponding template, providing an updated template bundle, and then updating the environments or service instances to use the latest versions. AWS Proton gives you the right blend of control and flexibility so everyone can focus on innovating for your business. If you'd like to try these examples for yourself, check out the sample templates repositories linked in the video description or visit aws.amazon.com/proton to get started today.